Hello, everyone. I hope you're having a good time at reInvent this year. How many of you expected a truck to be driven onto the stage during the keynote? It makes me wonder how we'll top it next year. That worries me more. But thanks for coming. And my name is Balaji, the first speaker on your list there. And today, I hope to talk about compliance and PCI, right? A lot of you in the room are probably having challenges moving your PCI workloads onto AWS. Now, there are patterns that suit a lot of companies that may not be applicable in the enterprise space. We'll try and focus on the enterprise patterns today. And by the end of the session, I hope you'll have some notes to take back and implement in your own PCI adventures, right? By the way, can I ask for a quick show of hands? How many of you have live PCI workloads running on AWS? Excellent, excellent. And any QSAs in the room? Ah, there you go, there you go. OK, guys, keep me honest, OK? So it's great. Thanks for coming again. And what we'll look at today is quickly go through PCI. I'm pretty sure all of you are familiar with it. But look at some things that influence the design. And then we'll look at what we heard from you, folks in the room, as well as folks who we worked with throughout the last 12 months trying to develop some solutions for PCI. And when we look at what the solutions are, some considerations that when you're designing for your own organizations, what should you take note of, especially with regards to PCI? We'd look at enterprise patterns. And then today I have Rolando from Time Incorporated, a customer who's made the journey and has PCI workloads that have gone through assessments today. And he's going to talk about his experiences. And then I have Brett Miller, a colleague, who's going to demo one of the solutions that we came up with. Let's get into it. We'll try to make it short. So if someone's timing it, it should be less than 3 minutes. Okay? So we are focused on the data security standard, which is operated by the PCI Council, which is an independent standards body. It also has multiple other standards related to the payments world. We are not going to be looking into a lot of that. We are focused solely on the DSS. And the reason that the PCI is so prevalent is because of the founders. And when I say founders, you have to look at who, nope. Not these founders. These are the founders that we worry about. So between these 5 companies, pretty much any entity that deals with card data has to follow a certain set of rules. So that makes these set of rules pretty unique, because they apply to the mom-and-pop shop as well as to the payment processing company that deals with millions of transactions a day. How do you make a standard for something like that? And that's where some of the uniqueness in the breadth of how PCI is applied will affect our solutions. And it applies only when you store the primary account number or the credit card number, store, process, or transmit. We are at currently version 3.2. I don't know if you're familiar, but AWS was validated pretty soon after the 3.2 was released. In the creation of our solutions, we've also incorporated guidance from other information supplements that the Council releases. Not just the DSS, but where they talk in detail about penetration testing or tokenization, which really don't apply to our solution, but they also provide some guidance which could be used, like in the cloud security guidelines that they released a year ago. So we've taken into account whatever they've said in general about payment card security. The payment card lifecycle is about 3 years. The standard is looking to improve. They take note of emerging technology. They provide input on new types of risks and adopt new ways of mitigating those risks. And AWS is both a participating organization, and Amazon.com has a place in the board of the PCI Council. And we also participate in the special interest groups that the Council does from time to time in order to look at emerging technology. So we try to provide feedback back into the ecosystem for resolving some of the challenges that we see in the customer arena. what have you folks been telling us in the last year? There are at least 70 services. I know we released the last over the last 2 days. I have not yet had time to count again. But with this number of services and the many different ways in which you can put them together, what is the right way? What is the compliant way to do it? And then how am I going to come talk to my assessor about this? How do I tell him the risk story? How do I show the mitigation that I have performed in my architecture? These are challenges that you have communicated to us. And then we have customers like Time Inc. who have decided to go all in and benefit from cloud technology. That means the security workloads, which were traditionally on-prem, are now on the cloud. Control frameworks have to be molded to cloud environments. How does that impact an assessment? Where do you keep your audit trails? Do you have the same processes? Do you have different processes, et cetera? And then the speed of deployment, right? We've heard about continuous integration, continuous deployment, et cetera, over the last 2 days. And how do you get compliance baked into it? Do we still go in at the end of change and say, is this compliant? Have you, X, Y, and Z built into this product, or do we bake it in? And vendors are an important part. Will my current on-prem vendors meet the requirements of a cloud-based workload? Will they be able to scale? Will they help me adapt to infrastructure that's here today, gone tomorrow? Those are questions that come up repeatedly. So we decided to summarize all that and see what we could do about it. There are things that you as customers still own and have to address in your own context. But we decided to look at how we could help you at least get a quick start or a jump start. And that's where the reference architectures come in. Not necessarily reference architectures which are compliance down and only talk about how you address compliance, right, on AWS. But from AWS up, how to continue to use the same benefits that the developers go to the cloud for, to address your security challenges, and also to give them a less constrained environment in which they're able to operate freely and solve business problems while you also meet your compliance goals. And so we tried to come up with not a white paper or a diagram. We wanted to do something that would be ready to use, and that's where we provided CloudFormation templates in one of the solutions that we're going to look at today. Is CloudFormation familiar to everyone? Good, everyone? Okay. So the next step, obviously, is that the general guidance is not going to work for everyone. We have enterprise customers, we have payment process, we have point of sales, et cetera, all these evaluating on AWS. And some are even running production workloads. We've had customers go on stage with payment technology, talk about how they met PCI DSS. So their needs are different. The way in which they use credit card data is different. So we have to have a second solution that addresses those kind of unique cases. So we have worked out another way to do that as well. So the first solution for general use cases and common patterns is going to be the Quickstarts. So this is publicly available. Whatever we know, whatever we've learned, we've codified into a CloudFormation package that you can launch into your AWS accounts. It comes with some additional documents that will help you understand how compliance requirements are being met. And during the demo, Brett will help walk through what those documents are. Going on to the specialized use cases, we have a way of delivering a compliance playbook. And we go through a phased approach in order to get to that playbook. We address complex use cases. We address customers who deal with credit card data in a unique way. They may be part of a payment stream. They may be talking to acquirers or merchants. And they have certain ways in which they need to manage their compliance. Not just because it's on the cloud, but because it has to integrate with what they have already, right? And that's where we have professional services engagements to help those kind of customers meet the PCI requirements. So I'm going to go to some considerations that you as security architects and security professionals can take back to your companies when you're dealing with moving PCI workloads. The first thing that really stood out is even though PCI DSS is the same for every application deals with it in a different way. That's because what they do with credit card data is different. They may be storing it, processing it, or transforming it and sending it to another service down the line. And because of that, the controls that are applicable and the way in which those control requirements are met are different. And that was a good learning for us because we couldn't just come up with a way to meet all 400 controls that would apply across every application in your enterprise. The second is as you move from an on-prem control environment to a cloud-based environment, it is not necessary that you have to replicate every control that you have. You can look for new ways. As long as you're meeting the intent of the control and you're mitigating the risk to credit card data, it is OK to have a control that looks different. We've built these controls over a period of time. We trust them. They've been in our toolkit for a long time. But if they don't match up, don't hold on to them. Look for controls that you can easily automate. Why? Because as you saw in the last 2 days, there is a lot of focus on DevOps, and there's a lot of focus on continuous integration and continuous deployment. And during those kind of deployment models, how are we going to have a check-gate process that stops a build from being deployed, verify compliance requirements, and then let the deployment go through? It has to be automated. And so the controls that we build up also have to be automated in order to scale. The other consideration is most of the PCI, though it has a large degree of specificity, and some people like it, some people don't, but it is what it is. There is a measure of risk assessment in the standard. An example here is whether or not you decide to use a web application firewall, right? The control allows you to choose a control, which can be a web application firewall, or it can be an annual web application penetration test or an automated test. Now, because of how each company has traditionally addressed the risk and the vendors they prefer and the security mitigation types that they prefer, these kind of controls are different. And so your path or your application path through the decision tree will be different from another company's or another entities. So we'll see why this matters. In a compliant framework that you've built in your on-prem environment that's grown over the years, you don't have a control that stands out by itself that protects you against all types of risk. You have a system of controls, a framework that works together in mitigating risk to credit card data. And as you can see, 6.4.5.3.b is not going to stand on its own unless it's tied in with all the other sub-bullet points and things. And this kind of tight coupling is hard to mirror when you start moving controls into AWS. Because as you move one control, it impacts multiple other controls. So you have to take that into account when you start designing your control environments for an AWS workload. So how did we do that? How did we approach this problem at customers? Rolando is going to talk about his journey in pretty much a similar phased manner. I'd like to just point out the deliverables that come down in each phases. In phase one, what we deliver is the high-level design. And this should be familiar for a lot of folks who worked on ITL-based projects. The intent is to give the DevOps teams and the other cloud teams enough material for them to go ahead and build their proofs of concept, to go ahead and build out the infrastructure and iterate on the final solution. Now, if the application teams are going to be deploying every week, or every month, or even every 3 months, that means the application is going to change every 3 months. So security practitioners, how much can you predict the future and put in place a comprehensive framework? The answer is it's very hard to do that. A better approach is to iterate along with them. And I'll go back to one of my previous slides where I called out that the decision tree that you go through is also going to change as you iterate. So the best possible way in which to help enable those teams move securely is to look at what they have today and so resolve for that. And the end goal being PCI compliance. Just as they move to the end goal or iterations, you can move through iterations to the end goal. So we give some high-level things, right? In the first thing, let's say, how do you have your VPCs architected? How many AWS accounts do you have? What kind of security groups do you have? How will your identity and access management roles flow together? So these are things you can give out as guidance at the initial stages for the teams to iterate upon. How do you address log trails? What log trails need to be turned on? So these are things you can definitely give out. And then in phase 2, you're going to look at recommendations for the gaps that you identified in your control areas. And then a resolution could be that you move something you have on-prem onto work cloud, or you extend something like a logging and monitoring solution to look at information and audit trails from the cloud-based workloads, or you could look for vendor solutions to address some gaps that you today don't have in your on-prem environment. So that's the second phase. And the reason that you start that early is some of those may take time to go through your purchase processes, your governance process, and be implemented. The last stage, just before your assessment, or as early as possible, is when you get into the details of 6.4.3.b and say, this is how I address that particular control, and this is how I documented it, and then that becomes your evidence or assessment work paper to provide to your assessor. And a point I want to make here is that whenever we did deep engagements with customers with unique and complex use cases, we took the feedback and we tried to generalize in terms of raising the bar on what could be achieved for everyone, and then we rolled that back into the templates, the PCI and the NIST templates. And we made it publicly available just because the more people use it, the more we're going to learn about how to handle these patterns on AWS. So let's see about actually putting some pants. So I'm going to talk about some patterns here, right? And we'll start with account credentials. There's a lot of documentation out there on how to handle root account credentials, how to handle access keys. I'm going to focus on what the PCI looks at, or what are red flags for assessors. When you're going through a review or an assessment, the privileged access functions are pretty important to take care of, right? It's not going, you're going to have deployment frameworks or deployment engines, tools like Jenkins, which push CloudFormation onto AWS. They're always going to have some privileged functions. And then in a truly automated pipeline, users shouldn't need access to the environment. But that's rarely the case. There's usually some troubleshooting, some kind of break glass access that's allowed in that environment. The idea is segregate the things that you think are important. I would point out that if someone has the ability to delete your log bucket, that is a critical function. If someone has the ability to create new access roles and policies or modify access roles and policies, that is important. If someone has the ability to turn off or turn on CloudTrail or config, that is your audit trail data. Your assessor is not going to be happy if you miss 3 months of audit data because someone turned it off. So these kind of functions, put it into a special policy. Give that policy or access only to a specific set of people. Put in multi-factor authentication on it so they explicitly have to assume into that role in order to use those functions. So that way you have a clear audit trail. Usually it's a good practice to attach some kind of change request to that access. And federation, right? Federation is good for enterprises in general, but in the context of PCI, it's important because that's how you deal with onboarding, termination, and job changes. And you don't want to have a separate set of process for your AWS user accounts versus your on-prem user accounts. And those controls have been tested in place for a long while, so it's better to leverage them through the use of federation. Segmentation, or requirement 0, right? Subnets have traditionally been how we've dealt with segmentation. We've always said when we have a new workload that has a sensitive data classification, let's create a new interface on the firewall, let's put the subnet behind it, and then route all the traffic through that new interface. And then that's a new secure subnet. We no longer have to follow the same pattern. Subnets are now free to do the job that they're meant to do, which is networking, and then we have security groups to help us with security tiers. Let's see how this changes our traditional view of infrastructure a little bit. NACLs, I'll talk about security groups in a bit. NACLs are associated with subnets in the AWS world, and NACLs can be used as good second-level barriers. They shouldn't be used for detailed port-level filtering, because that's not what they're for. Things like not letting the database tier talk to anywhere except your app tier is one of the use cases for NACLs. So in that case, even if there's a failure and a mishandling of your security groups, you still have an additional control that prevents your database from talking to the web tier. So that's how you should think of NACLs as, more as guardrails and high-level barriers than port-level filtering. Security groups, I've described a pattern here, and the architecture that you see here is something we actually delivered to a customer. And you'll notice that we have 3 subnets in there. But you can also collapse those 3 subnets and make it 2 and still be able to meet PCI requirements because your security zones are now in the security group tiers. We have 4 security group tiers there. A pattern that I've seen customers use is they will have 2 security groups per tier or per instance. And the first security group will just allow every access that is needed for the functioning of that server. Things like NTP, DNS, logging, all those routine operational things that need to happen within the EPC will be handled by that first security group. And then the second group is tier-focused. It'll allow traffic between the tiers as you want it to happen. So in this, you'll see that the first subnet or the public subnet is the PCI implementation of a DMZ. We talked about automation. There's going to be a lot of sessions here that cover how to do automation using Lambda and CloudWatch events and CloudWatch alarms and things like that. So I won't go into that, but I want to point out that one thing you can look for and confidently do in terms of automated policy enforcement is if someone tries to implement a rule that says 0/0 allow any, then that you can confidently say that's wrong in a PCI environment. Even if it's production environment, that rule shouldn't be going in. So that's a use case where you detect and put in place some kind of role that reinforces your policy. Maybe remove the security group or send an alarm, whatever it is that works within your environment. So a little bit of automating the PCI controls there. We have customers talking about using a shared services VPC. It's become a pretty common pattern now. You'll probably see it in your organizations as well. The shared services VPC is used to hold all the services that are used by multiple applications, things like logging, or things like your domain name service, or identity and authentication, your Active Directory. These sort of services can generally be allowed in the shared services VPC because they're consumed by multiple applications running in other VPCs. But the shared services subnet is usually unique to PCI environments because you can actually relate each of those things that go in a shared services subnet with the PCI control. And the reason is it makes it easier to have those kind of security constructs closer to the workloads that they're meant to protect in terms of opening up the ports that they need in order to do the job. And an important point here is that deployment tools are also being uniquely made available in the shared services subnet, if only because having one set of deployment tools for PCI means the audit trails associated with those deployment tools are the only ones that are in scope for PCI. And so you can have a greater degree of access control over those systems. And because deployment tools have privileged access into your environment, it is also vital that you don't have too many people with the ability to deploy into that PCI application environment. So dedicated versus shared. We've also had customers, especially customers with limited team sizes, ask us if it's okay to mix PCI and non-PCI workloads. The answer is it's not against PCI as long as we have the adequate security groups and other tooling in order to enforce segmentation. But you do want to look at your advantages in using a dedicated PCI account. And you do, because of the stronger isolation that it comes with, and because you don't need to allow a lot of people access into that environment, your assessments are going to flow that much easier. There's less amount of assets to look at. That brings down the amount of licenses that go towards your host-based controls, your other monitoring and antivirus-type controls that require licensing. You can also have a lot of simpler IAM policies because the number of users are going to be lesser. If you look at shared, it does make sense if there's one team and they want to operate in one way. If it's one team and they have to go to 2 different Jenkins consoles to deploy infrastructure just to keep those access management things separate, then it really doesn't give a good experience for those teams. In those cases, there is a case to be made to say, let's combine all of them. But the caveat is, now a pattern that you should go after is to have the common baseline for all of these workloads in there. And if you're using the same deployment mechanisms, then make sure that you have all these entities in the shared environment meet the PCI requirements or more. So we talked about PCI services and getting PCI workloads onto AWS. You're probably familiar with a lot of the PCI documentation that is available on our website. Now, I've had customers repeatedly come and ask me, you know the service that was mentioned in the keynote? I think that would make an absolutely fabulous use case for my end user. I think it would save me a ton of time. Why can't I use it in my PCI environment? Right? It's hard to say no if there's a legitimate business case that supports it. But you want to take into account that when we validate a PCI service, when it comes up on the list of validated services, what it means is we validate that the logical and the physical infrastructure, as well as the management and operational process, are meeting PCI requirements. It has nothing to do with how you use the service. You still have the onus to secure it, use it in a responsible manner, and meet PCI compliance requirements. And that's why when you have a requirement to use a non-validated service, you still have the same responsibility. And it's good to talk it over with your QSA or your solution architects to be able to understand what it delivers to your environment, right? If it actually helps you improve the security of card data in your application, then that's a good, strong use case to take to your QSA and say, I'd like to be able to use this. How can I make this happen, right? And I do want to say that this is a double-edged sword, so do talk to your QSA before you start considering usage of non-validated services. So these are some things I'd like you to think about in terms of risk. There are no clear indications of what is good or what is bad. There's a lot of difference in how companies deal with this. But these are things that come up during assessments and not generally during deployment, build, or design. So I'm trying to give you the cheat notes for your assessments, right? Network time protocol. A lot of customers are used to building what they have as a network time server that is meant to provide time in a secure manner to their PCI workloads. It is a PCI control, and over time, those NTP servers have been built in a certain way and operate in a certain way. Now, they do bring those type of workloads onto AWS, but if your expertise is not in managing NTP servers on virtual instances, and you really don't want to be doing that, you can leverage the Amazon-provided DNS names for their ntp.org NTP servers. And that is a good pattern as well, because now you'll be able to match up your CloudTrail, your config, and other data within the AWS environment to operating system logs and things like that. Bastion hosts have also become a common pattern. You'll probably find them in a lot of cases. But with regards to PCI, it provides you a way to minimize your attack surface. And two, it provides you the ability to enforce multi-factor authentication for operating system access, even if you don't have federation for operating system access. So that's, on top of that, there are folks who have gone in and said, I need additional audit trail of what's happening in my environment, so I will put in things like session recording or some kind of additional log monitoring. Server-side encryption. It's good control. It's easy to turn on. Most data store services support it. And if you turn it on, be sure to supplement it or add another encryption control along with it. And the reason is the SSC as it stands doesn't meet PCI requirements for encryption. So you have to have additional requirements on top of it. Your own encryption solution, maybe using KMS or Cloud HSM or something like that. HIPS is a host-based intrusion prevention system. It's not necessary that you have to port your network IDS onto AWS. HIPS and HIDS will do an adequate job of meeting the controls. There are customers who are using this today. So coming down to the SSL realm, I'm not sure how long it's going to take to really phase out all the SSL versions that are insecure, the ciphers that are insecure. But in between, what do you do about the legacy applications that are being moved to AWS? It turns out that the ELB can be your friend there. By offloading your SSL to an elastic load balancer and then having a cipher policy that actually meets a secure requirements for SSL by enabling TLS and additional ciphers that are going to pass your PCI scans, you will be able to have a better degree of security for those legacy applications till the time you manage to update them. Automating security policy. I gave you an example with the security groups. Another example ties back to the privileged role of function that I mentioned earlier. Now, if someone is trying to use an IAM privilege in a policy which is not whitelisted, that is another pattern that you can absolutely detect and either alarm on or go in and say, I want this user to be denied all access till the time I'm able to investigate and find out what is going on. So that is the kind of control automation that you should look for. There are multiple audit trails in AWS. People focus on CloudTrail and config, but S3 has access logs, ELB has access logs, RDS has logs. So be sure that you have an inventory of what those logs are, what is available to you, and ensure that they're being filtered into your SIM platform or your logging platform and then being looked at on a daily basis or as needed. Partners come up often because some of the things that we looked at are being solved by partners, and so giving them the time, giving them the bandwidth to be able to provide a solution before your assessment is important. It's not nice to have it come up 30 days before an assessment and expect a solution, because that's probably going to be very stressful. So with that, I'll try and leave you with some things to take away. Do take a look at the PCI DSS Quick Start. In case you have workloads that are today candidates for this kind of reference architecture and you'd like to participate in the development of future versions, do come by either in the feedback or in person and let us know that you're willing to be part of that, and we'll try and reach out and get something going. And then going back to customization, the baseline is just that, a baseline. You have to come down and then customize it based on the controls that are important for your environment. Scope creep happens more often than necessary. That is because as applications change, they tend to pull in data from different sources, deliver data to different places, and then you have to keep a strong eye on it so that when your assessor comes and look at it, it is what the scope that you looked at when you started. And go ahead and do some automation, test your eyes out so that you get the experience to be able to automate more controls as you go on in the next year 1 and year 2 of your PCI journey. And with that, I'd like to ask Rolando to come up on stage to talk to us about his journey.
Okay. Thank you, Balaji, and that was a great presentation. And thank you again for the opportunity to tell a little bit about my journey or timing's journey of PCI to the cloud, or specifically to AWS. A little bit about me. I'm the global director for the InfoSec team and incident response for Time Inc. For those that know Time Inc., Time Inc. is the biggest publishing company in the world. We have video content, we have even TV content, but we have hundreds of titles, some of which you might be familiar with, titles like Time, People, Fortune, InStyle, and Sports Illustrated. I focus mostly on cyber detection, cyber protection, security engineering, security operations. So there's definitely no short of stress there. My boss says that, this jokingly says, there's a couple ways you can deal with stress in this profession. One of them is to, you can either laugh, cry, or drink. Obviously, I choose to laugh. But on occasion, I do drink and I cry alone in a room where no one can hear me. So in my early days, I started as a double E, and then I moved into telecom, networking, and security in the early 2000 years. So again, I'm here to talk about the PCI journey to AWS. The story is really going to be unique to Time Inc., but I'm hoping that some of the steps that we took will be familiar or relevant to you, and hopefully insightful. So I'm assuming, I think there was a show of hands before, but there's quite a lot of people here that are already in AWS, but I'm assuming that most of you are either in AWS or thinking about going to AWS. Just if it's your first time going to AWS and you're thinking about putting your PCI environment, I would suggest that you really have the right processes in place, you have the right resources with talented developers, and you have the right partnerships in place, especially with your internal teams, as well as any other partners that you guys may use, vendors, or even your QSAs. The reason I said that because, putting PCI in AWS or any other environment, brings the ante up a little bit on how security and compliance needs to be handled. So the business comes to us and says, we're moving to the cloud. We're moving a PC environment to AWS, make it secure, make it compliant. So, oh crap, right? So that's when you decide to either drink, cry, or laugh. But really, you have a decision to make, right? I'm taking this from the Matrix, right? You can either take the blue pill and basically tell the business, listen, we're not ready, or we don't have the right resources in place, or maybe we feel like AWS is not secure enough, or if you are like Time Inc., you take the red pill, and you see how deep the rabbit hole goes, and it goes really deep. So take the red pill. Just a little bit about where we are today compared to where we were about a year ago. We actually started our deployment to AWS about 2 years ago. But we're almost there at 100% at AWS, and really this year was the first time that we decided to move our PCI workload to AWS. That was in Q1 of 2016, to the point where we have now two deployments. And we started with our digital public-facing sites first, and then we moved to internal applications. So we had already some background and experience with the whole AWS ecosystem to the point where we felt confident enough to start moving our PCI environments. So, while the overall migration process, if you first start with, just your traditional data centers and move your workload, or if you're moving PCI, well, that process is generally the same. We had to make sure that we had the right policies and standards and procedures in place. So one of the first things that we tackled was to construct what is called, the PCI Framework or Playbook. So what is the framework or Playbook? It's essentially the mapping of existing PCI controls and using those results to create a playbook. And if you think about this, 400 plus controls that you probably need to worry about. That number changes here and there, but there's 400 controls essentially, or more than 400 controls that you have to worry about. So, we took some basic steps. There's definitely more steps, but just to break it down into make it simple. Let's say we use the discovery phase. This is the phase we kind of broke it down into two sections, into questions and challenges. So as far as the questions, obviously there's more than these. I just highlighted some of the ones that we felt were important. But has anyone done this before? That's the first question we ask. How can we tap into those resources and try to get some idea of what other people have done in the past that would help us understand what we need to do as well. How the QSA will interpret the new environment, right? This is, I guess, where the value of AWS professional service came into place, at least for us, because not only they are experts QSAs, but also they know the AWS environment, they know the ecosystem, they know which services are PCI compliant and so on. But, it really became a lot of help for us to help us understand which controls were the ones that we needed to focus on the most. There's other things like, for example, like what security tools are needed to meet PCI requirements. Obviously, those are questions that will come up as you think about migrating your PCI environment to AWS. So as part of the challenges, obviously, at least for time being, we have multiple business units with different operational models. And, for us, it was like, okay, how do we construct this framework that would essentially apply to all these different models, right? How do we standardize that? And it was a challenge for us in the beginning, but, eventually you get to understand, that you essentially, you will come to an understanding that, and a coordination with all the different teams that will make it easier for you to understand those models. Security and monitoring tool transfers. So for example, like I said, part of the question was like, how would our current tools and monitoring methodologies transfer, let's say from a traditional data center, on-prem data center to AWS. Balaji mentioned firewalls, for example, right? I guess you can choose to put firewalls at AWS, but then you'll be funneling all your traffic to one or two different areas. That's probably something that you not want to do and take advantage of the AWS environment. So, so you rely on things like security groups or NACLs, right? And segmentation, which is really important. And that's how we address the issue with firewalls. PCI controls transfer in AWS, really which controls fall under the responsibility of Amazon AWS and which controls fall under the responsibility of timing, for example. So just to give an example of that, physical security, right? Something that you don't have to worry about at AWS. Essentially the QSAs will ask you for an attestation of compliance, an AOC from AWS, which you will provide to them, and it will list all the different controls that Amazon is responsible for and they're compliant for. Or something like a requirement 10, like monitoring. In your traditional on-prem, you may have an IDS system that has a tab to a subnet that you need to inspect for traffic analysis, right? That doesn't really apply so much in AWS. So how do we deal with that? We bring our IDS down to the host level. So we deploy host level IDS, for example. From a planning perspective, what we feel as a planning perspective is basically defining the roles and responsibilities. So I think it's, like Balaji mentioned in his presentation, there's really important is to stress the need to have partners and partnership, especially with your internal teams. There's a mutual collaboration between the teams, especially between InfoSec team and the DevOps teams. And there must be something that you have to build into the process, right? You can't just let the DevOps teams go and deploy whatever they want. They have to comply to some of the controls that we establish. So we sort of take like a DevSec approach with that, whereas the developers are not just only the operation and engineers, but also they become your security practitioners, right? So it's definitely important to embed information security into that process because in a way we drive the policy and standards and they have to essentially make sure that those controls are deployed in the correct manner. So kind of a little bit more on that, at Timing we have really 3 tiers within the InfoSec team. One of those is application security, GRC and IR. Again, same, incorporating those processes or those responsibilities into the DevOps team. And like I said, we kind of take also a security by design approach, right? So if you think about some of the things that we would do, like monitoring, for example, how do we ensure, or what we do is we basically code into our CloudFormation templates our IDS agents or our AV agents, and that's part of how we inject ourselves into that process. And obviously you want to ensure that you have your login set up correctly, that you have a CloudTrail, your S3, maybe you have MFA delete to, all of that needs to be kind of determined into your templates before you deploy it. And that's how we try to impose ourselves into that process. So as part of the implementation, I know there is, there's really 12 control, but when you add self-control, I talk about having 400 plus, right? I want to give you an idea of what we did to meet some of these controls, and I highlighted at least these 4, the ones that we felt were more important, but really also the ones that the QSA kind of focus on the most. So to give you an idea, control 3, which is the protect store and credit card data, that essentially says that encrypted your data at rest. And the way we did that, we actually used field encryption software from a company called Protigity. We decided to use Protigity because it was available already as an approved AWS, and it was available for us to use. So you can easily use KMS, not only to do your encryption, but also to be able to rotate and manage your keys. But we decided to use a different approach. Control number 4, encrypting your data in transit. Obviously use TLS, use certificates from a trusted CA. One thing to point out here is that, at least for us, once your data hits your VPC, right, you don't necessarily need to encrypt the data within your environment, which is your PCI environment. But we chose to encrypt it end-to-end just because we wanted to meet the highest levels of security within our environment. So essentially, once the data hits our load balancers, we re-encrypt it and send it back all the way down to the different stacks into the database. Restricting access to the cardholder data. So make sure you're definitely segmented from the network. One good practice, which I think Balaji mentioned as well, was to make sure that, as a good practice to have one AWS account for all your PCI workloads. Obviously, there's no mandate to have different workloads under one account, but as a good practice, I would not mix your PCI with non-PCI environments in one AWS account. I would keep that separate. Identity and authentication access. So from a good practice also, we don't allow access to our environment for management via the public domain. So there's no jump host that you can actually access from the public domain. All we do is all the access for us is done via our internal network, via a direct connect link, which is essentially the authentication is done via SAML, which is essentially tied to our Active Directory, and is front-ended with multi-factor authentication. So you cannot make any changes, you cannot log in to any of the environments without multi-factor authentication, which I think is one of the things that you have to implement. And then the authorization piece really is leveraging Active Directory object groups and ensuring that only the people that need access to certain parts of the environments are the people that have access to it. And then on top of that, we don't allow root access account. So, security 101 at AWS, don't use your root account. So definitely that's something that you restrict. So from a validation process, we think of this as the layers of the process. Continuous monitoring is something that definitely we're looking to automate in the future. But as of now, we partner with a company called AlertLogic, who is essentially our MSSP, and they have different tools. One of them is called Cloud Insight, which essentially allows us to check a configuration against AWS security standards. So that gives us, and obviously you can set up some alerts and based on certain protocols or conditions. So, that's one way for us to make sure that we have continuous monitoring. Obviously, we deploy different other tools like VMS to continue to scan our network, whether it's external or internally. We do code review. There's many different layers, just to name a few. Proper documentation, that's something that was kind of strange for us this year, because the QSA, it seems like there's an emphasis on the QSAs to pay attention to documentation. For some reason, it was something that we had to work on a lot compared to previous years. So definitely ensure that you have the proper documentation and is updated. They're looking to see when the last documents were updated, whether it's a process, a procedure, or whatever it is. I'm sure some people may have documents that were written 2 years ago without being updated. So those are the things that we're focusing on, which for us was strange, but I guess important to make sure that we have that in place. Process improvement, obviously we talk about automation, maybe do a little bit more like security by design, or maybe incorporating the DevSecOps approach into our strategy. Having a PCI readiness plan. So, conduct a gap assessment annually, create a year-round program to essentially conduct or do continuous audit. So essentially, automating your audit process. So a few key takeaways. Definitely know your environment, right? Know the AWS environment, know the AWS security concepts and PCI concepts. Define your cloud requirements. Definitely reach out to all your vendors and your partner solutions. Work with your QSAs and identify, the key areas of compliance. Collaborate with your internal teams. That's huge, right? Whether it's your partner or your internal, right? Before your internal teams go rogue. Definitely perform application assessments, whether it's pen testing, external, internal. There's things that you have to do as an ongoing basis. Your audit readiness. So basically create your PCI playbook early on and incorporate it into your DevOps model. Continuous monitoring, self-understood, and definitely test, right? Don't put your PCI environment without any testing. Do a lot of QA before you roll out your environment. And that's it for me.
Great.
So thank you, and I think Brad is going to do a demo now.
Brett, thank you. Now we'll go through a demo of the PCI DSS Quick Start. And Brett, do you want to go ahead?
Awesome. My name is Brett Miller. I'm one of the team members on our Enterprise Accelerator for Compliance program. The entire idea is to try to make things a little bit easier because I don't think anyone thinks compliance is really easy, do they? Probably not, right? So what we've tried to do is try to take a lot of the best practices and roll them up in templates and provide a lot of documentation around those templates that you can give to your auditors to show how you are compliant to PCI and other third-party frameworks. Using our Quickstarts, we tried to make it as easy as humanly possible. Everything that we have is actually on our public websites. If you go to our Quickstart page, which is at aws.amazon.com/quickstart, you'll see that we have three Quickstarts available. For PCI, you can click PCI, or you can go into some of the artifacts that we provide. There's pretty much three major pieces that we provide in all of our packages. We have a deployment guide, which gives you a lot of information on what is going to be deployed by these templates and how to use these templates and modify them in your own use cases to make them very customized to your environment. That's the one piece. We also have obviously the CloudFormation templates themselves. We've created about 8 to 10 nested templates that you guys can use as building blocks, which will go from nothing to a fully compliant, production-ready environment that's PCI compliant. We put a sample app in there just to show how an app can reside within this architecture, and we also provide a lot of the PowerPoint presentations that you can actually edit for your own to customize that so you don't have to recreate a lot of the artifacts yourself. Probably the most important piece of all of this is actually our security controls matrix that you can download as well as an Excel spreadsheet. This goes down all the PCI requirements on the left-hand side and provides descriptions on how that control is actually met in this reference architecture that you actually just deployed. It'll tell you which template actually deployed that configuration and how that maps all the way back to the API or the resource that actually provides that type of control in this reference architecture. Very important. Suggest everyone go ahead and download it and take a look at it. We'd love to provide feedback on that. So how easy is it? We try to make it as push button as possible. If you go to our deployment guide, really all you have to do to make it nice and easy is actually just hit a button, right? Launching the Quick Start. Launching the Quick Start automatically logs you into your CloudFormation, basically pulls the main template out here. You hit next. It's going to prompt you for parameters in order to customize this PCI compliant environment. You have to just give some very few parameters like a database password. You have to choose the SSH keys you want to use for the environment. We do support AWS config rules. So if you want to automatically deploy config rules that are going to help monitor PCI compliance, you can do that. You choose your availability zones, and that's pretty much it. You hit next, next, and done, right? Automatically behind the scenes, the system is going to start building the PCI compliant environment with multiple VPCs, all the audit and logging automatically turned on, everything that you would see in a compliant environment that Quickstart will actually build out for you. Now, not telling people are going to use these in productions. What we encourage you guys to do is to download these templates that we have on the page and customize them to your own needs, right? Rip out our sample application, which is WordPress, and put in your own. The idea is we're going to do a lot of the heavy lifting around the automation and the documentation so you don't actually have to do it yourself. So as it builds, it's going to start building the stacks. It's going to start with a lot of the IAM and the networking and work its way all the way up to the application. When it's finally done, what you'll see is multiple stacks here that built the system from start to finish. We have the main stack here, which is like a main function, and then starts calling all of the subordinate CloudFormation templates in order to build the environment as in about 30 minutes. After it's done and everything says complete, you can actually go into the outputs. And as I said, this is actually going to have a sample application, and we actually have a landing page to make sure that actually everything configured properly. You basically click on our landing page out of the outputs in CloudFormation, and it's going to bring you right to the page that's going to basically tell you that everything completed successfully, and it's also going to give you links directly to a lot of our artifacts from here. You can get it from other places, but this is another place that you can get these directly from us. It's going to have links to the architecture diagram, the CloudFormation templates, the matrix, so on and so forth. So we encourage you to go out, take a look at it. It takes about 30 minutes to do. Download those templates, look at our matrix, and see what you can use. You may not use all of the templates or all of the artifacts, but it'll really give you a kind of an accelerant to get to PCI compliance relatively quickly, at least at the infrastructure layer. If you have any feedback, we do have feedback forms. We're always looking for input. If you guys have any questions, please reach out to us directly. I was going to hand it back to Bilal, as he can give you some last statements, and we'll be done.
Thank you, Brett. That was a good demo. I don't know how much time we have for questions, or if there are questions. Okay. We have a great reInvent, everyone. See you next year.